Hi there, Felt Tips here for Tuts Plus, and this is a tutorial about debugging expressions. So it's kind of for intermediate to advanced expression users. That means you're probably pretty much an advanced After Effects user if you're at that level. You're probably someone who's moving on from kind of short 3, 4, 5 line expressions into things that are a little bit more conceptual, perhaps a bit more abstracted, and you've probably noticed that the debugging tools in After Effects are not exactly, existent, really. That's the problem. And what this tutorial is about is a kind of a workaround about how to get a glimpse at the kind of intermediate values that are happening in an expression. What's happening to things at lines before you deliver the final result. And it uses a text layer, essentially. It uses the source text property of a text layer, for the simple reason that unlike other properties such as position or rotation, the source text property is much more forgiving about the types of input it can allow. Basically, it needs a string, and After Effects expression language is pretty good at converting stuff to strings, whereas a position requires an array of 2 or 3 numbers, and the expression language isn't so clever at converting things to arrays of 2 or 3 numbers. So you see, you can use a simple text layer in quite cunning ways to kind of dig below the surface a little bit, not only of your own expressions, but of the expression language itself, and see a little bit what's going on under the hood. So I think it's going to be a tutorial in kind of 2 parts. First of all, we'll just look at some cool stuff that you can do with the debugging layer. We'll write a little function that kind of shows you the methods and properties of an object. And then I've got a little example that I've written, an expression with 5 particularly thorny errors in. So we'll then go and kind of use a debugging layer to get to the bottom of what's wrong with that expression. You'll find all of this stuff in the project files that come with the tutorial, so have a look in those as well. So let's just kick straight in. I think it's sort of best demonstrated, really. We're just going to make a text layer. We'll call it debugging layer, like that. Put it in the middle of the screen, a simple text layer. And just to sort of demonstrate initially what I'm talking about, let's pull up the sort of position here as well, and the scale and all that sort of stuff. And you can see on a 2D layer here, we have sort of 630 by 438. We can alt-click the stopwatch and we can type that value, an array 630, 438, no problem, into a text layer. We could take the rotation value of 0, like that, and the text layer's source text property will display that, no problem. If I was to come into position and I was to type in 0, I'll get an error. It's the wrong type of data. It requires a value that's an array with a length of 2, not a single number. So, when it comes to your source text, let's get rid of that there now, it's not just arrays and numbers or Boolean values that it can accept. It can accept most things, pretty much anything that can be converted to a string. It could accept a string itself, the word 10. Or it could accept an array of strings, 1, 2, 3, like that. It can display that too, or we can throw in a couple of numbers, for instance, 4, 5. It can do that too. We can look at things like this layer. We get an object layer. Now that's not something you always see when you're dealing with After Effects. You're sort of getting a glimpse of what's going on below the surface. If we just type in layer, we're getting a piece of native code. We're getting a function that creates a layer. Likewise with this comp and comp. You can also look at kind of homemade objects. You can just create an object in the standard JavaScript way and you get an object, or you can use the longer new notation like that. Or you can look at standard objects like the math object, for instance. You can look at things like Booleans. You can do comparative equals, 10 equals 12, false. You can have a look at null equals 0, true. And how about null equals 0, false. The triple equals, incidentally, compares not only the value but the data type as well. They have to be the same to return a true. So you can see it's really important when you start to write longer expressions that you know the kinds of data that you're dealing with. Expression language is pretty good at converting data to the right type, but there are plenty of situations where it doesn't do exactly the right thing. Let's just take the example of position. Let's just sort of pick whip position here like that. Now, the debugging layer shows us that is an object property. It's a kind of container that contains a value. And if we put .value on the end of it, you can see that we get the value, and then we can add which part of the value we require. In fact, you can even use a shorthand to that and get the same thing. But if you just use position, you get the object property. Generally speaking, that's okay. After Effects knows when to convert to the value, but sometimes it's not okay, and then it's really important to know. The debugging layer can help you with that kind of stuff. In fact, there's even a keyword which helps you with this kind of thing. It's called type of. It's a JavaScript keyword, and whatever comes in brackets afterwards, it will return a string of that particular data's type. So there you can see we're dealing with an object. If we put in a number like that, we get a number back. We can put in a string. We could put in a null, an object. We could put a comparison, 10 is greater than 3, and we get a Boolean back. How about an array? 1, 2, 3. That's an object too. Well, that means that we can tell amongst most things, but it's going to be rather difficult to tell between an object, a new object type of object, and an array. They both give back the same thing. While I'm on the subject, a quick test for that. We'll just make an array like this, and we'll make a new object, and we'll put the new object into the variable b and the array into the variable a. And what we can do is we can just test for the length property. If we do a.length, you can see that a length property exists for the array, but it doesn't for the object. Problem is, we get an error. But in that case, again, type of comes in very handy, because if I type in type of and then b.length, it tells me that that particular property is undefined without actually throwing an error. So a test for an array is simply this. Test the object using type of and make sure that it's not equal to the string undefined. So b is not an array, a is an array. Very simple. So now you can tell an array as well. I'm just going to pick up the older position property once again into this variable a, and I'm going to show you another little trick for showing all of the kind of properties of a property, or all of the methods of a property, all the things it can do, all the functions it has. It comes by way of another object called the reflection object. So if we type in a.reflect, you see that we get an object reflection. If we then type in a.reflect.properties, you can see that we get a great long list, well, not a very long list, an array apparently of different properties that the position property has. And if we type in a.reflect.methods, you can see we get a list of the methods that it can use. Now, because this sometimes gets a little bit off the screen, as you can see, it's quite nice sometimes just to format it a little bit better. So the first thing I'm going to do here is to actually try to make a function that sort of formats this information a little bit more nicely and returns it, and can be used for any object that you throw at it. So let's have a go at that. We'll call it get props. We'll have function get props like that. And then we will pass the argument, which will be the property we want to look at. We'll call it aobj for the sake of argument. And then we'll just have var tprops is equal to aobj.reflect.properties, like that. What we then need to do is to cycle through that object.reflect.properties. And the first thing I ask myself is that an array? So what I'm going to do straight off is just do type of a.reflect.methods, just to get an idea of what we're looking at. It's an object. But is it an array? Let's say a.reflect.methods.length. It apparently is an array, and is the properties. Yes, So therefore we should just be able to pull things out by number like that. So back down here, I'm going to initialize a string and I'm going to put some initial information in here. I'm just going to say object plus aobj.name. Now we assume that it has a name, and what we'll do is we will, at the end, we will return tstring, and up here we'll just call our function get props a. Okay, and we've got object position. That seems to be working. What we'll then do is we'll cycle through our tprops. So we'll have var I equals 0, and then I is less than tprops.length. That's the length we looked at before, and then I++. And what we'll do is we'll just append tstring with the number, then a dot and a space to make it look nice, the property itself, again convert to string, and then we'll put a hard return at the end just to make a nice looking list. Let's see what we get there. Okay, it looks pretty good. It's sort of going off the screen a bit, so what I'll do perhaps is just shrink it down a little bit. And there you can see we've got, oh hello, I can see something I've done wrong. I should have when I put a hard return at the beginning as well. Just make it a bit neater. There you go. So we have an object, it's called position, and these are its numbered properties. Now from that we can very easily make a get methods function. So we just copy and paste, we'll call it get methods like that. And we just need to change the last property there to methods. And now if we call get methods, it would help if I'd spelt the name of the function right, I guess. There you go, that's better. And there you can see we've got a kind of numbered list of all of the methods of the position object at the top there. So if you ever want to kind of get a quick look at all the stuff that you can do with any particular thing, I'll tell you what, let's just throw the math object at it. Let's see if this holds up now. Let's just chuck the math object in there. Okay, we have a little bit of debugging to do. And we can see that we don't actually have a name for math. That will be to do with the line here where we've used aobj.name. Now that brings me back actually to our type of. So what we'll do here, we'll say type of aobj.name is not equal to undefined. And we use a thing called a ternary, which is a bit like a sort of an if-else statement. You put a question mark and a colon. And after the question mark, we put the value that gets returned if this statement is true. And in that case, we know that aobj exists, so we can use it. Otherwise, we'll just return the string unnamed like that. So I think I'm going to have to just quickly carry that over to the methods one that we're calling as well, actually there. So let's just paste that in there. There you go. So you can see object unnamed. If we use the math object, it doesn't have a name property, whereas if we use the position, we have the position in there. Now we've got a pretty robust way of just having a look at the properties or the methods of any object that we care to throw at those two little functions. And those are in the downloaded After Effects project file for you as well. Okay, so next up we are going to go and have a look at a kind of a real example where we're actually going to try and debug something which has got some nasty errors in there. Okay, so without further ado, let us launch in on a real-world example. What you'll need for this is the project files that come with this tutorial. I guess you might want to work through it yourself, but I'll just show you what we've got going on here first. First of all, we have the working circle. This is an expression that essentially sends this red circle on a little looping journey around 4 targets. Those are here. If I just turn those on, you can see target 1 is this one, target 2, target 4 is the next one down at the bottom, and target 3. But the red circle is actually moving around them in name order. We can change the layer order around and it still follows the same way. Working circle itself has 2 effects on it that control the movement. We have a completion slider, which is a percentage. It goes from -150 up to 260. That would be a total of difference of 410. So each 100 corresponds to 1 full journey around. So you can see we start there and we go 1, 2, 3, 4 and a bit. And that corresponds to -150 to 260. And you can see that it works with negative values as well. If we turn the checkbox on, or off, should I say, for the looping, you can see that the behavior is somewhat different. Then it just does a simple linear journey between the 4 targets, stopping at the last one. It doesn't come right back to the beginning, and it does that between values of 0 and 100 on the completion slider. So a kind of simpler behavior, but we'll kind of start off looking at the looping. Now, when you look at this, you're going to find that there are 2 other versions of this circle. There's one with a non-working expression. It has 4 errors in there, and quite a solid sort of annotation about the errors, where they are, why they are, what you have to do to repair them, and so on. And this one here, this is more for the brave. If you want to go in and sort of try your luck with this one, try and debug it. This is just the expression with problems. The same as working circle, it's just got those 4 errors in. Before we actually kick off, I'm just going to go through and give you a kind of quick lowdown on how this expression works, because it's important to know. Generally, you will be debugging your own expressions, so you will kind of know what you intended to do. And so I'll tell you what I intended to do here, and indeed what I have done in this working version. First of all, we put this layer into a variable L, and then we pick up tloop and tcomplete variables from the effects on this layer. We also divide completion by 100, changing it from a value from 0 to 100 to values of 0 to 1, mapping it, so to speak. We now change tcomplete according to how tloop is. We're basically performing a modulo operation to make tcomplete as it goes up, 0, 1, 2, 3, 4, 5, 6. It counts up from 0 to 1 again and again and again. So it's 0.1, 0.2, 0.3, right up to 0.999999. As soon as it gets to 1, it loops back to 0 and goes again. So we've always got this 0 to 1, 0 to 1, 0 to 1. There's a little bit of logic built in here that just says if tcomplete is negative, then we add a very large number to tcomplete to make it positive. We're basically taking tcomplete and shifting it up the number line massively to the right, and then performing our modulo on it so that it, once again, turns into values between 0 and 1. The reason being that when you do a modulo of a negative number, the result also comes out negative, and we want to make sure that tcomplete is clamped between 0 and 1 and always moves in a positive direction as tcomplete moves in a positive direction. If we're not looping, we simply clamp tcomplete between 0 and 1. Next up, we build an array of target layers. We simply cycle through all of the layers of the comp, and if their name contains target, we put them into this array called targarray. Once we've built targarray, we sort it by name. Once we've done that, we come on to the most conceptually complicated part of the expression. What we're doing here is trying to find a sector that the red circle is in at the moment. Basically, if you have 4 targets and it's going in a loop, you have 4 sectors that the thing could be in. If you're not going in a loop, you only have 3 sectors, because the last one between 4 and 1 doesn't exist. So what we're doing here is we're actually setting num sectors according to whether tloop is true. Once we've done that, we're then mapping completion, a value between 0 and 1, to the number of sectors. So in other words, instead of going from 0 to 1 completion, we go to 0 to 4 completion if we have 4 sectors. And that's a float number, so it could be 3.25 or something like that. We then decide the sector that we're in by rounding down. If we had a sector float of 3.25, the sector is sector 3, and then by subtracting we get the completion. The completion is 0.25. So we're in sector 3, and we're 0.25 of the way through it. That equates to 0.25 of the journey between the third and the fourth target. We have another little bit of logic here as well. This is just if we're not looping, we make sure that when we actually reach the third target, instead of the modulo kicking in and saying, we're not in the third sector with a completion of 1, we're in the fourth sector with a completion of 0, which is naturally what a modulo would do. We're just saying that if we're at the end of the last sector or above that, we just clamp it to the number of the last sector and to a completion of 1. So it sort of stops at the final target that it wants to get to. The final stage is just to use the sector value to find out which two targets the circle is currently between. We then work out the vector between those two targets, and then we work out the position by taking the position of the first target and adding it to the vector multiplied by that sector completion, that 0.25 for instance that we had back here. So in other words, if we had a value of 3.25, we'd be in the third segment and we'd be 0.25 of the way along this vector. So we'd come to this point and then we'd multiply the 0.25 by the vector here. The only thing you need to be a little bit careful of when I'm talking about threes and third and so on, is that arrays in After Effects and in JavaScript, they count from 0. So in fact, the third sector, or the third element of an array, better expressed, is actually number 2. An array with 4 elements has elements 0, 1, 2 and 3. So you need to bear that quite closely in mind. That's how it works. Have a play around with it if you want to get more into how it works. What we're going to do now is we're going to go into the problem circle with no clues for the brave, and we're going to debug it and just find those 4 errors by using a debugging layer. So let's get on. First up, I'm going to make a new text layer, as you'd expect, and I'm going to call it debugging layer. Never type anything first time, do I? Let's pop that up there. Move it to the top just for convenience, and I'm going to come into the expression, copy the whole thing. There's an error, we're expecting that. We're going to come into the source text and alt-click the stopwatch, paste the expression in, an error which we're also expecting. And there's a couple of little things I need to tidy up first of all. Now, we're referencing expressions, effects on this layer, getting the values of those. And what we could do is we could copy the same effects over to the debugging layer, but I think a better idea actually is to reference the original effects on the original layer. So that's easily done. I've put this layer, as existed down here, into the variable L. If we change that to the actual layer we want specified by name, then we're getting the same layer as referred to in the expression if it were down here. We then just need to be a little bit careful that when we reference effects, we're explicit about which effects. We want the effects on layer L. And because I've used a variable to put this layer into, it means that I don't have to go and change loads and loads of different versions of this layer through this expression. So there we go. Let's see where and what our first problem is. Well, first of all, you can see that we've got an error at line 27. The nature of the error is that we have an array which is supposed to have a property or method named 0, and that's missing. Now, because an array, as I just said, counts from 0, element 0, or property 0 of an array, is the first element in that array. And it's a pretty good bet, it's not a dead cert, but it's a pretty good bet that if you're missing element 0 in an array, then you've got an array with no elements in it. It's empty, an empty array. What we're expecting here is an array with 4 elements in it, these 4 target layers that we've kind of gone through and put in. So my first port of call, I'm going to look at line 27 and see where this is actually failing. But my first port of call is to be having a look at our array, targ array, and seeing why, if that's got no elements in it, and if so, why it's got no elements in it. Now, unfortunately, After Effects doesn't give you any line numbering. A bit of an oversight, if you ask me. I wish they'd build it in. So what you tend to end up doing is counting down the lines. And actually, sometimes these little messages giving you the line where the error is happening are not entirely accurate. There are a few things where it's a line or 2 off. I'm not quite sure why that is. It's usually okay. So sometimes you do have to delve around and find the line a little bit. Perhaps we'll look at some other ways of doing that later, but bear in mind that the line numbering, unlike arrays, counts from 1. So the first line is line 1, and all lines are included, including kind of blank lines. So Line 27, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27. This is our problem line. So I'm going to use a block comment to comment that, and everything after it, slash star, star slash, out. Everything between the slash star and that star slash is now simply a comment. And then I'm just going to come and look at T. First of all, I'll have a look at T sector, because you can see what's happening here. We're taking tag array and we're looking for the property T sector from tag array. Let's look which that is. We assume it's going to be 0. It is. And then let's just have a little look at tag array. In fact, let's look at tag array.length, shall we, just to see how many elements there are in tag array. 0. No elements. Okay. Now that suggests to me that where we build tag array up here, we're making a mistake. So I'm just going to move this line up to there, and I'm going to move the beginning of this block comment to just after that. And let's see what the length of our tag array is at this point. Still 0. So basically tag array has the wrong length immediately after we've created it. Let's take a closer look at what's going on. We've got a for loop. I'm just going to break these lines out. I've put it all on one line just for the sake of compactness. So let's break that out into its constituent 3 lines. And let's see what's happening. A for loop basically iterates through a variable for a certain number of times. We have the variable I, arbitrary name. It starts at 1 for the first layer, and it loops through until it gets to the number of layers that there are in this comp. And each time it increments itself by 1. So when we come in, we set an array, tag array, to be an empty array. We set L to be layer I, well, the first one's going to be layer 1, and then we test, and we say if the word target is in the name of that layer, then we put it in the array. With this push, it puts it at the end of the array. So we can say with this one, there is no target in the name, it won't get added to the array is still empty. We come around, the value is now 2, we do the same thing again, initialize tag array, check whether target is in there, and if it is, which it is this time, target 2, we put it in the array. We now have 1 element in our array. Next time we come round, I is 3, we initialize tag array. Oh, that's the error. We're initializing tag array on every loop that we do, every iteration of this for loop, and that's wrong. We should be initializing the tag array right at the beginning and then filling it up. If we initialize it every time, we wipe what we've just put in there. So we would think if we then cycle through all the layers and the last layer is not a target layer, then we'll have no elements. If the last layer were a target layer, yeah, we'd have 1. But you can only have 1 maximum. It's just on the last iteration of the loop that would work. So what we'll do is we'll take this and we can either stick it outside like that, or alternatively we could put it after a comma in the initialization section of the for loop. These variables get initialized as the for loop runs, and that should, indeed it does, give us a tag array length of 4. So at that point I'm now going to uncomment that whole block comment I put in there, and fingers crossed that this will now activate. It did activate, didn't it? And then it suddenly didn't activate again. Now that very fact is also a clue for the keen debugger. Since CS6, After Effects has had this thing called the, now I can't even remember what it's called. Is it the Global Persistent Cache? It's something like that. But anyway, After Effects checks along all of its frames very quickly on everything you do. And what that tends to mean for expressions is that sometimes they compile at first, they activate at first, but as After Effects goes along and checks all the frames, it comes to a situation where that doesn't work. Somewhere around here, somewhere here, it's saying, okay, we've got a value that doesn't work. It may work on this frame, it may not work on this frame or this frame. We don't know that. That makes our job a little bit harder. But when we try to compile it, once again we get a line number where the error occurred, and this time we've got a very similar error. We're looking for a property of an array, but instead of looking for element 0 this time, we appear to be looking for element 4,000,002,000,002, which is quite a specific and very, very large number. Okay, we were at line 36, I believe, weren't we? 36. Let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. You can see this can get quite tedious with like 100 line long expressions. 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36. It appears to be this line here. Okay, it's good. At least we're getting things that correspond. It was indeed pulling a value out of an array, so we guess that probably is the right line. Let's comment that and everything afterwards out again. And let's just have a look. Well, we know that tag array is right now. We think it is. Let's just check. Tag array.length /length is 4. That's correct. So presumably it's T sector that's wrong. T sector. Well, that's right. And that boils down to the fact of what I was saying before. This lack of compiling happens not necessarily at the frame we're on. So let's just scrub along and see if we start getting any kind of wrong looking values for T sector here. Hello. That looks like a pretty wrong value. It happens just about there. Let's just have a little look at T complete here. I'm just going to add in plus space and plus T complete. Oh, okay. T complete also looks like it's. I was going to sort of see if that's when it goes negative. Let's just have a look at the. Let's have a look at the value down here. The original completion that's getting picked up. It does indeed look like we're getting this problem when we go from positive into like the negative zone. We're getting these extremely large numbers. Okay, so let's just take that for a moment and say it's T sector, or indeed T complete. That's the earlier variable that we set that's somehow wrong. And T complete is picked up here, and then we do some stuff to it here. So I would say our first port of call is just to check what's going on with T complete. Let's just move our block comment to comment everything else after that out, and we can just sort of shrink this down a little as well. Let's just have a look what's going on. So we actually haven't set T sector at that point, so we'll just look at T complete. That's what that error is about. Yes, we can see that T complete, which should be a value between 0 and 1, is actually an inordinately large value. So what's going on here? I'm just breaking this out into lines again. It's been sort of put onto one line for the sake of compactness. We've got a kind of if-else statement here. And that looks suspicious. If T complete is less than 0, T complete is equal to math.power 10 to the 12. And if we just take that out, I think we will see that that is exactly a 1 with a lot of zeros after it, a trillion, I think, minus T complete. That seems to be what's going wrong. Now the logic of this is that to make a negative value into a positive value, because modulo of a negative value stays negative, what we're doing is taking T complete and adding an enormous number to it. And that doesn't really matter, because afterwards we're going to be doing a modulo to it, and modulo will take that enormous number and it will convert it to a value between 0 and 1. So it'll just count 0 to 1, 0 to 1, 0 to 1. And you'll notice I said afterwards. Unfortunately, what we've got here is that the modulo is happening first, and then we're adding this huge number to it if we're negative, if we're less than 0. So I suspect if I put this modulo afterwards, in fact it needs to be after this part here, just in the... Actually no, what am I talking about? We do the modulo on the whole thing. Let's just put it like that, and let's just put this back onto one line. For neatness, compactness, let's see what we get there. Ah, that's better. A value between 0 and 1. That's exactly what we were after. So I'm now going to just try this out, delete that comment block and the extra bit that I'd added. Oh, we get a working expression. That's something that we like to see. So I'll save that at that point. I'll take the expression and I will paste it into here, and look at that. We also have a working expression. Let's just see how it's doing. Okay, Okay, well, we seem to be going first in one direction and then in another direction. It looks like we've got a little bit more work to do. Now, I'm going to bet that this kind of change in direction, just a hunch, is on the change of completion from positive to negative. So I'm going to come and look at that same place that we were looking before. T completion is always rising in our particular example here. It starts at -150 and it goes up towards 260. It's negative sometimes, but it's always rising. And I notice our problem seems to be either before or after the change from positive to negative. So it's probably something to do with this statement here. And if you think about it, if you're setting T complete to minus T complete, then, or something minus T complete even, then numbers that were rising would then be falling. If you negative something that's rising, then it's getting smaller instead of bigger. That's got to be our problem. And if you think about it, that I said you're going to take T complete and shift everything up by 1 trillion, then you need to add 1 trillion to T complete, not subtract T complete from 1 trillion. That's our problem there. Same place, so we just add it. Take this expression, don't forget this stage. We're going to paste it onto here. There we go. And now we go in the same direction. You remember me saying though that the targets go in a clockwise direction. There's 1, there's 2, there's 3, and there's 4. It should be going like this. How about if I put them in that order? What happens then? Oh, then it goes in the right direction. If I swap 3 and 4, oh, now it's doing something very funny. It strikes me now that our circle is actually not following according to the name of the targets like it should be, but following according to some other kind of order. So let's come in and have a look at that again. Let's move our debugging layer so we can see it a little bit. The reason that our circle is going in the name order of the layers is because we've sorted the array. That's the intention. So I'm going to guess that the problem is somewhere around here. At least I would very much like to know what the values are in the array when we sort them. So once again, I'm going to comment everything out until this point, and then I'm just going to put in targ array like that. Let's see what we get. Well, we just get object layer, object layer, object layer, object layer. And it strikes me that, first of all, not only can I personally not see which order those are in, it makes me wonder if After Effects can't really see what order those are in. And if we're dealing with the object layers themselves, what criteria is it actually sorting it by? I mean, we want it to sort by name, but maybe After Effects naturally sorts by layer number or some other parameter, the order they were created in, who knows. So let me just have a quick look and let's see what's actually in targ array 0. Okay, it's an object layer. Let's pull its name out and see what we've got there. Target 2 is actually in the first position. Target 4 is in the second position. In the last position we've got target 1, and in the third position we've got target 3. That's a kind of a weird order, and it doesn't actually correspond to name or to layer order particularly. Okay, well, what we need to do is we need to force the expression to sort by name. And what we would need in that case is that targ array not to be a list of layer objects, we'd need it to be a list of names, and then sort that instead. So where we build the array, a line back here, we can look and say targ array.push L. Well, let's just push L.name instead, and then we can see that we've got an array with target 1, target 2, target 3, and target 4. If we don't sort it, then it comes up in the layer in the order that they were added, 1, 2, 4, 3. Okay, so we can see that our sorting is working there. Brilliant, we now have a sorted array, and hopefully that will work. Aha! Okay, now we've got another error. And this one's fairly clear what's happening. It strikes me straight away. We've just changed something that's caused that error. If we change it back, the error is not there. So we've actually created some problem later on in the expression by changing that to name. And we get a clue about what that is, where it says the function ttarga to world is undefined. Now, where to world is a method, is a function of a layer, we can assume that ttarg used to be a layer and now it's something else, probably a name, a layer's name. So, which line was this? This is at line 39, and we're looking at ttarg.toWorld. Well, I'm not going to count on this occasion because we know that 39 is near the end, and I'm just going to look at the first place where we actually get toWorld. It's there, ttarg toWorld. It's got to be that line. Let's just check by commenting out everything afterwards. Yep, that's fine. And if we put that comment line after the line that I suspect is wrong, yep, we get the error. It's that line. There's no doubt about that. So once again, let's just come in and check some of our variables. ttarg seems to be the problem. Let's just type that in. It says target 3. And what I'm going to do too is probably just do a type of as well. And I guess that we're going to see this is a string, and it should be a layer object. In other words, we would have to do something like this comp.layer ttarg, do a type of that, and we can see that's now an object. And indeed, if I do it without the type of, we should just see that we get the standard After Effects notation that says object layer. There you go. So basically we need to convert, having changed that bit up here, we need to now convert back to an object layer from a name, which is a pretty simple process. We'll simply put a new line here that says ttarg A equals this comp.layer ttarg A, and ttarg B, because we've got another one that's going to do the same, is equal to this comp.layer ttarg B. We can then get rid of that and our comment at the end, and fingers crossed we've got something working once again. Let's just copy that. Let's paste it once again onto the position down here. Paste that in, and let's see how we're doing. Okay, we're going clockwise. Perfect. It's working. Let's just check the non-looping functionality. Let's close the debugging layer down for a second. Let's switch looping off and just scrub through. With looping off, it's still very much looping, it seems to me. Okay, one final thing to find, and I sneakily put this in here because it's a classic error. I kind of alluded to it earlier on in this tutorial. It gets me lots of times and it gets a lot of other people a lot of times. It doesn't happen that often, but it is a classic. After we've set tloop, what I'm going to do is I'm just going to comment the whole thing out here again, right from the beginning. I've got a little error there because I didn't put my end comment on. Let's just pop that in too. And then right at the beginning, let's just move this so we're looking at just the beginning of the expression. And once you get better at expressions, you'll get very good at keeping them compact, so it's just easier to navigate around. And sometimes maybe for longer expressions, I even break them out into Extend Script Toolkit, which is actually intended for scripts, but it's a good way to just sort of see line numbering and be able to find stuff rather more easily than you can in the window in After Effects. And what we're going to look at here is just the value of tloop. Well, it says that tloop is 0, and if I change it there, it says that it's 1, which is kind of what you'd be expecting. But if I put tloop to string, we get object property, and what we would be expecting is a boolean. If I put tloop.value.toString, oh, okay, then we're getting 0. Let's try tloop type of tloop.value. That's a number, but type of tloop is an object. And what that means is that when we're testing tloop by just saying if tloop, or where we're using ternaries, I think later on, with a sort of question mark here, tloop question mark colon, where the value of tloop dictates whether you're going to get this or that value returned. We're not looking at the value we're expecting. When you just put it in an After Effects expression like that, it kind of comes up with the value that we're looking at. But if we use type of or toString, it turns out that that value isn't actually quite what we wanted. We know that it's 0, and we could just put something like we could put a ternary here just to test the power of, we could have yes and no, and we would expect it to be no here, but we're actually getting yes. If we put tloop.value in there, we're getting no, which is what we'd expect. So it's very simple, and you should get into doing this as a matter of habit. Is when you set tloop, instead of setting it to the property, set it to the property.value, and then you definitely get the property's value and not the property object, and that's very important. We shall now take that and we shall paste it once again onto the position, and there we go, hopefully. Yep. Oh, whoa, one last little error. That's doing a little kind of jump, isn't it, at the end? So it's back to our debugging layer. I wasn't expecting that one. So we'll work it out, we'll go through. This is actually pretty good because I wasn't actually expecting this error, and now we get to see how it actually looks when I've really got something to debug rather than doing ones that I prepared earlier. I would guess, and it would seem to me, that we are not in the sector that we are expecting, that we are kind of jumping from sector 2, 0, 1, 2, clamped to completion of 1, back to sector 0 with a completion of 0 for some reason. My first port of call is going to be to comment all of this stuff out at the end after we've sort of set sector, and I'm just going to come and have a look at what sector actually is here. It's 0. Well, that's kind of obvious, I guess. And back there it's 2, and what should be happening is it should be stopping at 2 with a completion of 1 here, but for some reason it's going back to 0. Now sector is actually made out of sector float, so let's just have a look at what sector float is here. That's also 0. And sector float is made out of tnum sectors, of which there are 3, that's correct. 0, 1, 2, that makes 3. And tcomplete. So tcomplete is 0. It's coming up 0.98, coming up right towards, tending towards 1, and it's supposed to stop at 1, but it's not. It's going back to 0. Why is tcomplete going back to 0? So we found out that we're actually dealing not with a problem with sector so much as a knock-on effect of a problem with tcomplete. And tcomplete is set up here. So let's shift our little extra line in our comment up to there. I can see what it is. I think I can see exactly what it is. Do you remember when we did, that's why it's in there. You remember when we changed some stuff around here, it was that we had the modulo before the adding a large number. And that wasn't right because we were getting these very large values for t sector. And what I did, I took that modulo calculation and I took it from here. Oops, sorry, that's the wrong part. I took it from here and I pasted it after this statement. But I've accidentally, instead of pasting it directly after, I pasted it after this whole thing. And what's happened is we've ended up doing a modulo calculation not only when we're looping, when we want it, but also when we're not looping, and that's why we're setting back to 0 here, I think. So if I pop that afterwards, but inside the first part of that if block, and then I get rid of, well, let's just check that tcomplete is 1. It is now, that's good. Let's get rid of the comment and the last comment at the end, and let's just grab that whole thing, paste it onto the position, and there we have it. 1, 2, 3, perfectly how it should be. If we come into the loop, and this is the real test now, have we broken anything else? Turn the looping on, it's looking hopeful. We're starting there, we're going 1, 2, 3, 4 and a bit loops. Perfect. We have debugged. We have gone in, we found the problems that we were supposed to be finding, and one extra one bonus problem in there as well. So Have a play with it yourself. Have a go. Look through this. Start from scratch. Have a go with the for the brave layer. See if you can go through and find the problems again yourself, using those techniques of commenting parts out and using those bits that we discussed earlier on in the tutorial, just to look at how the values of things are changing through the expression. I admit it's not the ideal way to debug things. Ideally, you'd have a brilliant debugging tool built into After Effects, but until that day comes, we're stuck with this kind of stuff. And frankly, it does help you to feel more confident about writing longer and more complex expressions. I hope that helps. My name's Felt Tips for Tuts Plus. Thanks for listening.